Hello, everyone. I'm Samuel Oswald. I'm working at VITO. We're a Belgian research institute, and I'm in the remote sensing team. We're a large team which works on all kinds of different applications involving drone and satellite imagery. As the title of my presentation suggests, I work on drone applications for phenotyping applications. So I'll get into it. I wanted to start by showing a few images. Here's a very high resolution RGB image. You can see like a lot of details of the plants taken very close up. You could spot spots on the plants or other kind of features if there were any. For another one, here's a multispectral imagery. Multispectral in drones, if you've ever worked with them, tend to be at a lower resolution, typically 1 to 2 centimeters or lower, whereas this is also at a very high resolution, maybe what you would expect with RGB imagery. So how do we take these photos? You could probably think of a few ways. You have custom bespoke machinery, like in the first image, which can fit all kinds of imaging devices and other things. You might use a very high-end drone, which can support a high payload and take high-resolution images from a height. Or you could, of course, send PhD students into the field on bicycles. The trouble with these methods is, in most cases, they're not scalable. They're all either quite expensive or you're limited in the amount of PhD students you can exploit. And so what we have been working on at VITO is a new method based on our own kind of interaction with researchers in the phenotyping domain, and we call it drone sampling. And the idea is to get this super high resolution imagery at a low cost. So likely a lot of you are familiar with this when you're doing a field drone campaign. You typically want to get a high amount of overlap, and you work across a whole field. The idea being that you use structure from motion to recreate your image. And there is a lot of different outputs you can get, plant cover, plant height, plant health with multispectral. And you can also start using your object detection methods to start counting plants and this kind of thing. And so this has been fine for a while, but as you move into high resolution, you come across two key problems. The first one is that it requires a high image overlap. As I mentioned, the structure from motion method requires that you don't just take a photo of part of the field once, you take it multiple times so that you can get overlap of the images. The downside of this is that you then end up with the same parts of your field photographed over and over and over again. And this maybe was fine when we had lower resolution images and it was only a few gigabytes extra. But now if you're working on fields where you might be working at 1 millimeter resolution, this can get into hundreds of gigabytes of extra data that you don't really need and won't use. The second issue, kind of related to this, is of course the anchor points, which is why we need to have high overlap. So when we use structure from motion, we have an algorithm that looks for common matches between images and then use that to reconstruct a 3D model. Typically, for drone missions, we want to look at matching the images between dates, so we'll also align them to various GCP points. If you try to use a camera that's not a very high-end camera and want to use this method to get very high resolution, you'll probably run into a few issues. So on the right with image C, you see how we went trying to use structure from motion to recreate a field using 1 millimeter resolution in red, which just kind of failed because it couldn't find anchor points between all of the images. In yellow at 2 millimeters, which also performed a bit better, but didn't quite work. And then at 5 millimeters, it does work. But if you look at the images on the bottom left, you can see for our 1 millimeter image in BI, we did have high resolution and we could probably identify things like the wheat heads in this case. Whereas for the 5mm resolution, there's not really much you can get out of it. So whilst you cover the whole field, you don't get the information you want. And so that's the kind of problem that we have. So right now, to map a 1 hectare field at 1mm resolution, you'll probably need a high-end drone, which can be 70K, have a 55-minute flight time, and you will end up with about 335 gigabytes of images, which can just be hard to work with. It'll increase processing time. You also have to think about data storage, and if you want to scale this to multiple fields, it's going to become quite difficult. So our proposition then is the aforementioned drone sampling. And so this is made possible through things like the increasing GPS accuracy of drones. So typically in a phenotyping use case, you still do want to really accurately capture your plots. So we suggested RTK drone for this. And if you look in the top, you are probably just interested in your plots and not the whole field. So all of these areas in green, they're probably not interesting for your eventual downstream analysis. With drone sampling, we aim to just take photos of the plots, which will then cut down on all of the extra data, allow you to fly with drones that are more easily available, which are cheaper. You can fly more, you can process much faster. So it can be a big benefit when you do want to get these very high resolution applications. So yeah, how it works, it's similar to any drone flight that you've done. You'll have a planning stage, a flight stage, and a processing stage. In the planning stage, we want to create our digital plot design. And so this is maybe one of the things that you kind of want to work out originally. There's a few ways to do it. You might have a planting machine that allows you to very accurately locate the GPS coordinates of your plots. Or you can do a traditional drone flight earlier in the season, which can be at a lower and therefore easier to achieve resolution, and delineate your field using that. But from there, you will define your plot centroids, and then depending on what you want, you can think about the camera type required, whether it's RGB or multispectral, your required resolution. And then through the workflow we've developed, you can create a mission file, which allows you to upload it to a drone and then fly it. So yeah, this is the kind of comparison with the data requirements that we end up with. If we use this method, you can see that for a traditional drone mission, we're looking at hundreds of images, whereas it just gets down to tens or a few dozen for drone sampling to cover the same area. So yeah, this is just I'm not sure if it's playing, but this is a video of a drone flying with this method. I think we actually end up just having a still of that video, but off in the distance you see a drone. So if you want to see the whole video, it's very exciting, and you can come and find me later for it. Oh no, it does work. I just had to press the play button. There we go. Yeah, so this is just kind of how it works. You can see it's similar to any drone flight, but we don't have to fly it so high, so we don't end up with this need for anchor points, which are typically found between all of your different plots. You just focus on the plots themselves. And I think this one's also animated. Yeah, so from here, you don't need this image stitching. The kind of one thing that you lack here is this kind of plant height, which is obviously a useful thing to get for. That's still possible. It is possible to do a lower resolution and a higher resolution flight, and that can end up being a more affordable option than just doing a high resolution if that's what you're after. But it might be that you're not so interested in that, and you're interested instead in the actual output products themselves. So yeah, you can see that we still now have, with a much cheaper drone, these very high resolution images. And with that, we can look at our extra downstream products like object detection and what have you. So yeah, that was the kind of planning and flight and the processing in the end. I think from here, I can talk a little bit about what some of the things you might be interested in are. So this doesn't just pertain to drone sampling, also normal drone flights, but a lot of them are much more achievable with this drone sampling technique. Here is an image showing your object detection. So that's obviously becoming very popular now with the advent of AI and machine learning in the drone phenotyping domain. Other things might be looking at your kind of plant or gap count. So in this first image, we try to count all of the plants in a plot, but also where you have gaps, which is useful for finding your emergence in the field. As you go to the other end of the growth cycle, you'll probably be interested in what your yield looks like. So this is a pumpkin case where we calculated the size, so the width and length of pumpkins, which is obviously very indicative of what you'll be able to market in the end. Other things might be disease detection, and this is something that you really often do need very high resolution for. I think this is also a video which isn't playing, but now it should be playing. Yes, it's playing. So this is kind of a field that we had before. Initially, we did a lower resolution flight, and then we did a drone flight over it, and it kind of shows you for these plots the accuracy of this drone sampling method. So each of the plots, it is georeferenced over where we would expect it, and so this becomes comparable between dates. Compared to the last image, you can see that we have this very high definition image of the field, and so this becomes usable for things like the disease detection. So in this case, the plots are lined up between the dates, and you can see in some plots the deterioration of the plant leaves and where they remain healthy over time in others. And I think it goes on to show more of this. And of course, there's a lot of other things that we can do. Here's some that look at fruit segmentation. So when you have high enough resolution, you can also look at trying to segment your plant objects. We've discussed a lot about this. I think in recent years, we're moving away from things like just detecting how many objects you have and more towards what do the objects look like, how do they differ, and all of that kind of stuff. Weed identification is also important. I know this was this has been a topic kind of yesterday in the MLCAS, and also for many of you, since that can be problematic on the fields. And of course, the multispectral use case is also something that's quite interesting. So as we talked about in the past, when you looked at multispectral imagery, it was typically at a lower resolution, so you might be able to get ideas of plant health with your vegetation indices for a whole plant, but because of the mixture of pixels, you couldn't look at a leaf level or try and identify features of leaves. But this is also something that's possible here. So you can see here we have our NDVI for the leaves themselves, and you can see which ones have a high kind of healthiness index according to NDVI and where it is less than ideal. And this can then be related to biochemical processes or diseases. So yeah, I just wanted to then finish off by mentioning a bit Mapio. So Mapio is the kind of end-to-end workflow for drone image processing that we have at VITO. And so the idea is that we're experts on remote sensing, so on things like geospatial image processing and all of this kind of thing. Often, if you are working in plant sciences, this is something that you might work on yourself, but maybe it's not your core area of expertise, and maybe you want to partner up with another institution to do it for you. If so, that can be us. So yeah, that's we take you from the plan through to the flight analysis, connecting to your own downstream applications, and so on. This is kind of just a look within our web platform of what you can see with a traditional drone survey versus drone sampling. So yeah, you can see for this wheat field, you do get much larger coverage using a traditional survey. But usually this isn't really something that you're so interested in. Likely you'll want to get statistics on the amount of wheat ears or the size of fruits or whatever, but just representative of a plot. And so in that case, the drone sampling case will of course be more useful. You can see in the bottom left, a very high-end drone was used to fly this traditional drone survey, whereas for the drone sampling case, it's a drone that's much more accessible. Yeah, you can then extract plot statistics, as I mentioned. I won't get into this kind of stuff, but we do have a booth here that we're sharing next to the entrance door with ISTIC, the guys with the cool glasses. So we're happy to take you through a demo of any of the functionalities of our platform. And likewise for the actual planning and how you create these kind of mission files. So to conclude, as we have developed drone technology, image processing kind of capacity, storage and all of that kind of thing, the importance of image resolution for drone-based phenotyping has kind of increased quite a lot. But for a traditional drone survey to actually get this very high resolution, you'll typically need to invest quite a lot, and you'll end up with a lot of redundant data as well as that. And so our methodology is the drone sampling. So yeah, that can really take down your investment cost, the time that someone is required to be in the field, because when you are doing a drone flight, you need someone there to actually operate the drone. And the processing cost is down by quite significantly as well. So you will have results available for further analysis quicker. So yeah, that's my talk. I'm happy to discuss further at the VITO booth. You can contact me via email, and I will also answer questions now. So that's great.
Any questions? Thank you. Very interesting talk. I have two questions related with technical details. First one was, how did you decide the optimal number of sampling rate, or how you downsample the original data?
For the how did I downsample on the original one? In that original image for the downsampling, this was actually 3 different flights, if I understand your question correctly. So we used the same camera. I think that was a Mavic 2 at that stage, or maybe a Phantom 4, I'm not sure, but at 3 different resolutions. Yep, I hope that's was your question.
Yeah, thank you. That's good. And one suggestion for you was to maybe check on an accurate sampling theory coming from signal processing.
Mm-hmm.
That has a minimum number of sampling you need meet to guarantee you can reconstruct the signals in a perfect way. The second question I want to ask was, how do you decide your downsampling of the drone data will not affecting your 3D reconstruction or structure from motion, the future 3D model quality?
Sorry, how did my downsampling not affect the structure from motion? Or
yes,
so I think that in this case, I would say it didn't affect it. I mean, also because it was the different flights. For the upsampled flights, I think this is just when you have the 1 millimeter, it's just going to always be a risk. Sometimes you will have a flight at this resolution that does work, but it doesn't work consistently, we found.
Okay, interesting. Thank you.
Thank you.
Thank you so much.
Thank you.
My question is on data privacy and security concerns. How do you deal with that?
The data privacy and security.
Because there's a lot of data which come in, and how do you deal with that? Data privacy and security concerns of.
I mean, all of the data is stored securely. I think that the data ownership kind of depends on the kind of client that we're working with or the partnership that we have. For example, some really are going to want to protect their own data and then it's not shared, whereas others will want to kind of enter a research partnership where they do publish things. So we are kind of versatile, as we're a research institute that's kind of in the applied research domain. We work with both academic institutions but also private enterprise. And so there's different requirements depending on the job that we're doing. Sorry,
doing data share agreement with your partners, I think is one of the most unfamous, because that's one of the thing also I've been doing, sharing, having a data share agreement with farmers that they can be comfortable with their data, make sure you can be able to use that.
Indeed.
Diagnostics and stuff. I think that's one of the thing I use also.
Indeed. I think, the data sharing with farmers is important. For this, it's not often strictly our kind of domain to share the data with farmers, as we do work with other researchers and with plant breeding companies, other researchers. So often this is something that we work out with them.
Let's have one question. Thank you for your presentation. My question is, did you work about real-time data analysis by drone? I mean, did you put some custom software in the drone? After then, the drone gets an image. After that, the same time, data analysis.
No, so we don't do onboard real-time processing for the drone imagery. I think I understand what you're getting at, where you could kind of, try and isolate the plot within an image and then take the image at that point. I think that's a future step that's very interesting, but not what we're looking at now. So how it works now is that we look at the kind of the plot centroids, and we already have a predefined flight path that we utilize.
Okay, thank you so much.
Thank you. Thanks a lot.
Thank you very much for this talk. Now we're going to continue with our well-deserved coffee break, and then at 16:25 military time, we will continue. See you back.